Okay, and I will show you a better picture of that. Okay, this is a better picture. Have you seen that before in furniture? Chairs. This is a classic joint, right? Where you put some glue on this, right? Put some glue on here, and maybe even in there, you fit it together and you put a nail on it or whatever, and then it's a nice and strong joint made. Yeah. Legos. Legos. You know what? I'll bring that into the conversation in a bit, but it's about the same idea. So Caden will know better than everybody else because he's in the wood shop. Maybe some others will do it later on. Maybe next semester. What happens if this piece right here, the tenon, what happens if that is made too small? Like if this piece, like the width of this piece is too small compared to the mortise, what will happen? It's going to be loose, right? It's going to be a terrible joint. It's not going to be strong enough, right? And what happens if this is too big? It's not going to fit. And if it could be that it fits just barely, but if you try to actually press it in, what's going to happen to the other piece is it might crack, right? It's going to put stress on it. So that's tolerance. But there's going to be an acceptable range of values that you do take. Like I told you, like pictograph, you always walked around with a measuring tape or a caliper. And when you machined, you would say, let's say my instructions were to make sure this is 45 millimeters. What if I measure and it's 43? Will I chuck it? No, because they told me it's okay to be under by a little bit or over by a little bit. They told us what was acceptable. Otherwise, you'd be chucking tons of material and you would lose a lot of money. So in every industry, there's a little bit of leeway, and we talked about it. There's human error, there's machine problems, there's a lot of things that will make this be off by a little bit. And so Yuri talked about Legos. Actually, Legos is a good example. You know how they're supposed to fit perfectly? If the Lego company wouldn't make sure that, right, those pieces fit perfectly together, if it's too loose, it's going to fall apart. If it's too tight, it's just not going to be able, you're not going to be able to build, right? But there is a little bit of leeway. Yeah. What's that? Yeah, you have to use your teeth to get that one out, right? So don't lose your teeth over Legos, okay? And then here is another piece that I want you to highlight is the nominal value. Nominal value is the target measure of what you're aiming for. So let's say going back to this example, it's supposed to be 45 millimeters. That's what we're aiming for. If it's 44, it's okay. If it's 46, it's okay, right? So, but nominal is what we're aiming for. Here's another one. The tolerance is determined by subtracting the minimum values from the maximum acceptable value. This is the one that I'm a little bit, this is a little controversial. The province doesn't see it this way. Just underline this part. It's saying that usually halfway between the minimum and the maximum values is called the nominal value. And I will say this, not always the case. And a manufacturing tolerance. So tolerance can be written in 4 ways. This is something, if I were you, I would add this to my study sheet. Maybe wait till we've done a few examples. But these are the 4 ways of stating tolerance, but this is not, this is a little shifted because of the PDF document. So let's rewrite it. Minimum has the tolerance here and minus 0 there. And the maximum will have the tolerance here, but it will have a 0 up there. So this is one way. This is another way. This is another way. And this is another way. And we will scratch these ones, so we're not confused as to why are they there. Okay. I will say this study sheet. It looks terrible. Study sheet there. Okay. Question. Tolerance. Sometimes, like let's say you're building a runway for airplanes to land. Is it okay to be over the minimum? Is it okay to make it a little bit longer than what they asked you to make it? Yeah. Shorter? Making it shorter would be a bad idea, right? Run out of runway, you don't want to do that, right? What about a dosage, like a vaccine? Is it okay to be over on your dosage? It's probably dangerous, right? Would it be okay to be a little under? Yeah, the damage is not as severe, right? It would just not, maybe not do what it's intended for. But so there are certain ways that there's a limit on the upper end and nothing on the lower end, or vice versa. So it's depending on the situation. Okay, now go with me on the next page here. So 93. So I'm going to walk you through all 4 of these. But from all 4 of these, you can deduct or take out I wonder if I should do this here because there's a star here. Can you go back to 92? Sorry. So much work, right? Seriously. You know how it says minimum and maximum? Those are also, though, called in brackets. Make sure it's in brackets. It's our nominal. In brackets, it's also our nominal. So basically, that's what we're aiming for. That's what we're aiming for. So you've got nominal, nominal. You see nominal here, right? Does this form have nominal in it? It does not. That's the only one where you cannot tell what the nominal is, what we're aiming for. We're aiming for this here. We're aiming for that. We're aiming for that. These are all going to be numbers later on. Now we go to 93. Okay. So let's talk about the first one here. If it looks like this, you will basically have 15 centimeters and 12 centimeters, let's say. I'm just giving you one example. This could be millimeters, grams, degrees, it doesn't matter. But you'll have 2 numbers like that. You should recognize that this is the format we're talking about. And so all of them have you're able to get the max out of it, the min out of it, the tolerance, and what the nominal is. Those 4 you can always tell. You just got to know what you're doing. Okay, you just got to be able to do this. Some are just as easy as looking at it. So if I recognize that there are only 2 numbers like this, I will just obviously assume that this is 15 centimeters. Done. The lower number is going to be my minimum acceptable measurement. Tolerance, you got to do a little bit of math here. What was tolerance again? How did we, what's that?
Pardon the interruption. This is a final call for any students from grade 9 through 12 who have submitted an immunization form to please head down to the cafeteria right now. This is a final call for all students from grade 9 through 12 who have handed in an immunization form to report to the cafeteria. Thank you.
The range of acceptable. Let's do some just common sense here. So that's correct. What is the range of acceptable values? It's between 15 and 12, right? Here. The tolerance is determined by subtracting the minimum from the maximum. So why don't we do that here? Tolerance is going max minus min. If you want to put this down here, great place to put it. That is if you don't know what it is by first glance, at a first glance. If you don't know what it is, you got to use this one. Okay, so then that means in this case, we don't know at first glance what it is. So we go max minus min, which is 15 minus 12. In this case, the tolerance is 3 centimeters. They're tolerating a 3 centimeter difference between the highest and the lowest value. Okay, that is what we're after. The nominal, we don't know what it is, so we're going to assume it's the middle. So we go max plus min divided by 2. That should ring a bell. That's like finding, remember when we did the median? If you have 2, you want to find the middle, just add them up, divide them by 2. So 15 plus 12 divided by 2, that's 27 divided by 2, that's 13.5 centimeters in this case. So we were able to figure out all 4 just by looking at a few things. I will say this, aiming for it, right? Aiming for this. That's what we're aiming for, to be over and under. Okay. What if it's written like this? So let's say you have 17.5 millimeters plus or minus 1/2 0.4 millimeters. If you see this and I'd say, hey, look at this tolerance, you should be able to look at your study sheet and be like, oh, wait a minute, this is the only one that has that half thing there, right? So this is the format that we're talking about. So again, max, min, you don't have to do it in this order. I just keep it in this order. Max, min, tolerance, nominal. Which one is easy to just read out? What's the 17.5? It's the nominal, so I'm just gonna go arrow and just go 17.5. Done. Do I need to calculate my tolerance in this case? Tolerance is whatever's inside the brackets. So just read it. Just 0.4 millimeters. And now you have to do some work with the max and the min. Just like before, to get the max, we got to go this plus this. To get the min, we're going to go this minus this. So just follow me. 17.5 plus half of 0.4. We're going to go right next to it. 17.5. What's half of 0.4? 0.2, right? Just so you know, this shouldn't scare you. This is just saying divide this by 2. When you have a half or a third, if it's a third, you divide it by 3. Half is just this divided by 2. So this we can do mental math on, right? So 7.7 millimeters. That's the greatest amount allowable measure. Okay. The min is the same thing, 17.5. Instead of doing this whole thing again, I already know that this is 0.2, right? Half of 0.4. So I'm just going to go minus 0.2. And that is 17.3 millimeters. So question, if I measure and it says 17.29, if I measure something and it's 17.29, would it be acceptable or would I chuck it? Come on. If something is 17.29, this is technically 30. 29 is less than that. So because this is the smallest acceptable and this is the largest acceptable, you would chuck it. If something is 17.30 or 17.31, it would all be allowed. Okay? So you just gotta be careful with that. Next example here. Minimum value. This is a little, it didn't work out. It shifted on me. But I'm just gonna give you a number here. What if you have 5 degrees Celsius plus 2 degrees Celsius minus 0 degrees Celsius? Again, we're gonna go max, min, tolerance, nominal. Which one can I read right off the bat? Well, this is the one that students mix up, min or max. On your study sheet, where's the 0 at? Here. It's at the bottom, right? Just like here. So this is minimum. And if you're not sure, just go 5 minus 0. You get 5, right? This is 5 minus 0. That's 5 degrees Celsius. That's the minimum. So just go minus if you're not sure. And the max would be 5 degrees plus the 2. That's 7 degrees Celsius. So you've got your max, min. How do you get the tolerance? Remember, tolerance is max minus min, which is already here. But I would say always to make sure, just go max minus min. You will never be wrong. So 7 minus 5, that's 2 degrees Celsius, which is what we had here in the beginning. But you just make sure, if you're right, subtract these two that you found already and just plug it down right there. Nominal, what's my nominal? What is it? 6 maybe? I hate to say this, but let's go back once. What did I write under max and min? That they're also nominal. But Gino has a very good point. He said 6, he said in between. What's the only time we're going to do that? It's when you are given this one. Then you have to assume it's in between. But if you're given any three of these, the front number is also your nominal. So it is your min and it is your max in this case. Let's do another one. 0.5 ml. We have plus 0 ml minus 0.1 ml. Max, min, tolerance, nominal. I'm going to highlight that in a bit. There's three forms where the nominal sticks out right away. And it's this one as well. So let's make sure we get this covered. This is out of the question, done. We're done with that. Then you can do whichever other one you want, but to get your max, you just go 0.5 plus 0, which is 0.5 ml. To get your min, you go 0.5 minus 0.1, which is 0.4 ml. Your tolerance is max minus min, which is 0.1 ml. It happens to also be in here. So you've got your four things stated there. One last thing, because I just saw that I'm trying to make your life easier, even though I know this is my least favorite unit, probably for most of you as well. If you grab the highlighter, I just want to show you this. 17.5 is your nominal. 5 degrees is your nominal. 0.5, which happened to be the first number, was your nominal. So that's for those three, the last three we did, the first number that's standalone is automatically your nominal. The only exception is that top one, which I will tell you this, that won't happen very often. The first one, you won't have to find the nominal very often. For sure not on a test. For sure not on a test. No worksheet or anything today?